Hello students, in this video I am going to show you 5 techniques to prevent overfitting in your deep learning models. You will see these techniques in TensorFlow keras with examples, but let's first discuss what overfitting is. So overfitting is a phenomena where your model learns noise in your training set. You can see here this dataset has slight noise in the form of these orange triangles here and this blue square here. So when your model tries to learn these patterns, it also learns the noise. So this model has very sharp edges and it shows that it has learned noise in your dataset. When you try to make predictions using this model on test set, the model will not generalize well because the dataset in the data in the test set might not look like this. It may look slightly different. But since your model is trained too much on this noisy dataset, it will not be able to detect patterns in the test set. Now let's see how you can detect or find if your model is overfitting. We will see this with the help of an example. So I will import some libraries here to show you an example of how you can detect overfitting. So I will copy and paste this. You can simply copy and paste these examples, these libraries, or you can go to this blog here. I will put the link in the description and you can simply copy and paste the code. So coming back here, shift and enter will run this code. Now I will generate some dummy dataset from sklearn library. You can see here, I will run this code to make some dummy data. So this is a very famous dataset. It is called the moons dataset. You can make this dataset using sklearn library. So I will press shift and enter to run this code. And you can see our dataset actually looks like this. So it looks like moon here. You can see two moons that are intertwined into each other. And we will try to develop a classification model which can learn a decision boundary to classify the blue circles and orange triangles. We will divide the dataset into training and test sets. You can see this code here. Press shift and enter and it will divide the dataset. Next we will develop a machine learning model based on TensorFlow keras. Basically it's a deep learning model. You can see here. So I just copy and paste the code here. So this model has an input layer of shape 2 because we have two features in our dataset, and it has two dense hidden layer with the ReLU activation. The first hidden layer has 256 nodes and the second hidden layer has 128 nodes. And the final activation function is sigmoid because we have to predict one class, which is 0 or 1 in the output. And we are using binary cross entropy and accuracy as metrics. So this model is pretty complex. We will run this model and for 2000 epochs and see what results do we get. So I'll press shift and enter here. It will start training. You can see here. So I'll pause the video here so that the training completes. So the training has complete. You can see we got a training accuracy of 98.75 by the end of 2000 epochs and a validation accuracy of 80%. So to see if your model is overfitting or not, the best way is to plot the loss, the training and validation loss. You can do so with this code here. And you can see here, wow, yeah. So this is the biggest sign of overfitting. You can see that your training loss is decreasing continuously while your validation loss is increasing. So there is a very high divergence between two curves. So that means your model is actually overfitting. This is pretty obvious. This is the best sign that you should look for. And let's evaluate our model as well on the test set to see what accuracy we get. So again, so your accuracy on the training set was 98% and on the test set it's around 80%. So this is what happens when your model overfits. It has a very high accuracy on training set and a very poor accuracy on the test set. Also the loss for training is very less. It almost reaches 0 if your model is complex enough, but the loss for validation set will be very high. Finally, since we have two features in our dataset, we can plot a decision boundary as well using this ML extend library. So here you will also see that the model has overfitted. So another big sign of an overfitted model is it will have very sharp edges, sharp decision boundaries with spikes, as you can see here. So it's difficult to plot a plot which has more than two features. It's difficult to plot a decision boundary for such kind of plot. So I suggest that you always try to plot training and validation loss, and it will give you a pretty good idea of if your model is overfitting or not. So now we know that our model is overfitting. Let's see 5 techniques that you can use to actually reduce overfitting in your model. And using these techniques, you will see that your decision boundaries will be much smoother. So let's see the first technique, which is here you can see reduce model complexity. So one of the main reasons your model will overfit is because your model is too complex. It has a lot of nodes or a lot of layers, and the decision problem is the problem is not very complex. So the model is very complex. It will try to learn the noise in your dataset. So one of the things that you could do, in fact, the first thing that you should do is to reduce the complexity of your model whenever you are trying to reduce overfitting. So let's see how you can do this in TensorFlow keras. So we have the same code for the dataset. I will only change the model complexity here, and I will just copy and paste the code from my article. So now I have reduced the number of nodes in my dense layers. You can see the first dense layer has 8 nodes and the second dense layer has only 4 nodes. And here we had, I think, 256 and 128 nodes. So the model is significantly less complex compared to what we saw earlier. So I'll just press Shift and Enter to see all the remaining code remains same. Only the model complexity has been reduced. So I'll press Shift and Enter to see what training results do we get. So you can see by the end of 2000 epochs, now the the training accuracy is 87.5% and the validation accuracy is 85%. And also the loss is 0.29 and here the loss is 0.42. So this is significantly, the difference between training and validation loss is significantly less. We'll plot the training plots for both of them to see. Here I copy and paste this code. So you can see here the divergence between training and validation loss is very less. So the overfitting is less compared to highly complex model. So here you could see the difference between the loss, the training loss was 0.04 and the validation loss was 1.4. So which was almost, you could say, almost maybe 20 times more than the training loss. In this case, the difference is very small. 0.29 here and 0.42 here. Also, this plot shows that the divergence is much less. So reducing the complexity of your model may help reduce overfitting. Let's plot the decision boundary to see if the model has actually less overfitting. The boundaries are smoother or not. So I'll press Shift and Enter here to see that. So this code will run. So it will reach 9600 and then you will see the decision boundary. And yes, it's not ideal, but it is a little more smoother than this decision boundary here. You could see it is learning all the noise in the dataset, but here the model has simpler boundary. But this is not really ideal. In the ideal case, you will have really smooth boundary like this. So reducing overfitting is a good way to reducing model complexity is a good way to reduce overfitting in your deep learning models, but there are some many advanced techniques which we'll discuss. So the next one is early stopping. So early stopping is a phenomena. I will just paste it here to make a new section. So here, if you see this loss, you can see that around 250, around here at this point, the validation loss was minimum. So what if we stop training our model around this point? That is basically called our early stopping. In early stopping, you stop your training your model when you see that the loss is not further decreasing. You wait for a certain number of epochs, and after that you just give up. So to implement overfitting, to implement early stopping, all you have to do is in TensorFlow keras, you have to define this callback. So here you mention that you want to monitor validation loss, and you want that if this validation loss doesn't further decrease, this is mentioned by this, if this validation loss is not minimized or decreases for 20 epochs, you want to stop training, and you want that whenever the model has minimum validation loss, you want to save weights for that model. So because you could see that maybe you want to save weights at this point. So you have minimum loss at this point, you wait for 20 more epochs, maybe till here, and then you simply stop training, but your best model will be retained here. So this restore best weights does that. And in the fit method, you simply have to pass this callback to the callbacks attribute. So you have a callback attribute here, and you will pass your early stopping callback to the fit method. And now if you press shift and enter, you will see that, let's see, so your model stopped training after 63 epochs. So initially you had 2000 epochs, but in this case, after only 63 epochs, you achieve a validation accuracy of 90% and the training is accuracy of 92%. Again, the difference between training loss and validation loss is further less. So by early stopping your model, you actually save lots of computational resources as well, because you are not training your model for a lot of time. So you have two advantages. You reduce overfitting and you do not use a lot of computational resources. So let's plot the training and validation loss for early stopping. I'll press shift and enter. So the model will start evaluating on the test set. So you can see that your training accuracy was 92.5% and your test accuracy is 90%. So the overfitting is very less. And also you can see this plot here, and you can see that the divergence between training and validation loss is very, very less. So this is one of the techniques to reduce overfitting. Let's plot a decision boundary for this early stopping model. Press shift and enter here. So this is the decision boundary we get. As you can see, it's much more smoother compared to the previous two decision boundaries, and early stopping has actually helped your model to reduce overfitting. But early stopping is not the only solution. There is a very famous technique to reduce overfitting in your deep learning model. It is called dropout regularization. So I will add a section here, and I will show you how to add dropout to your deep learning models. So in dropout, basically what happens is you simply switch off some of your neurons. So you have like here you have 256 nodes in your first hidden layer, and in each epoch what you will do is you will switch off or simply not train 40% of the nodes. Similarly, in the second hidden layer you have 128 nodes. We will not use 40% of these nodes. So this here should be 0.4 here. The value of dropout, it depends upon your problem. It's basically you have to try and see which value gives you the minimum overfitting, but ideally it should be between 0.1 to 0.4, and that's all you have to do. So in this case we add two dropout layers, one after each hidden layer, and we are also using the early stopping mechanism which we used previously. So I'll press shift and enter. So in this case, the model only trained for 42 epochs, and let's see what performance do we get on the test set. So wow, so we had training accuracy of 90% and test accuracy of 95%, which is great actually. So, and we only trained for 42 epochs, and again the divergence between two losses is very less. So let's plot a decision boundary for dropout regularization to see if it's smoother than the early stopping one. So press shift and enter here. So this is the decision boundary we get with dropout, and you can clearly see it's much more smoother than the early stopping one. So early stopping still had some sharp edges, but with dropout we have a very smooth decision boundary, as you can see here. Another technique that is commonly used for reducing overfitting is called regularization. So you can see it here, and I'll copy the code for regularization. Again, you can find all these codes in my blog here, this blog. I will add the link in the description of the video. So to add regularization, you just have to pass regularization value to this kernel regularization. So in regularization, basically you penalize your weights. So because weights are what used to train your model, so you basically add some loss values, some more loss, some penalties to the loss values, which basically help your model not assign very high values to weights. So assigning very high values to certain weights can actually result in overfitting. If you try to keep your weight values less, overfitting will reduced, and kernel regularization, the regularization techniques basically does that. So press shift and enter to run this code. Again, I am using early stopping here. So now the model is only trained for 34 epochs, and I'll plot the model loss and its performance on the test set. So the accuracy on the test set is 90%, and the difference between the losses is also less here. Now we'll plot the decision boundary here. So here is the decision boundary for the regularization approach. It's less smoother than the dropout one, you can see here, but it's still more smoother than the early stopping one, you could see here. So regularization is another technique. Finally, there's one more technique which is not really used for overfitting. It is normally used to speed up your neural network, but as a byproduct, it can also help reduce overfitting in your deep learning model. So this is called batch normalization. To add batch normalization to your deep learning model, you have to use the batch normalization layer after each of your dense layers. So I'm using it here and here. I will simply press shift and enter to run this code and see what we get. So so the model is trained for 497 epochs, and we get a training accuracy of 95% at the end of 497 epochs and a validation accuracy of 85%. But since we are taking best weights, so we could see here we will get maybe 95% accuracy on the test set as well. So let's plot the loss and the loss for training and validation. Press shift and enter here. So you could see, because we are using batch normalization, the data set after every epoch is changed. So you will see a lot of fluctuation here, but at the end you could see that the divergence is very less. So whenever you use batch normalization, try to use very small learning rate in the beginning. Let's plot the decision boundary. Also, as I said, the accuracy on the training set is 95%, and also the test set is 95%. So I'll plot the decision boundary. And you can see that decision boundary is also very smooth. So these are the 5 techniques that you can use to reduce overfitting in your deep learning model. Personally, I prefer the early stopping approach. You should always use early stopping in your model, and in combination with early stopping, you should try dropout first and then regularization. You should use batch normalization anyways because it will help speed up your model training. But ideally, I recommend using early stopping plus dropout. So let me know which technique do you like the most and what works the best for you. And if you have any questions or feedback, feel free to leave it in the comment and also try to subscribe to my channel. Thank you so much.